Sometimes the universe does something strange with us. It doesn't explode. It doesn't send a signal. It doesn't open a portal. It simply drops something new into our path and quietly watches what we do with it.
Hi, you're on SkyMind, and today we're talking about an object that arrived here from beyond our solar system. The third confirmed interstellar visitor ever observed, 3I Atlas.
Is it just an ordinary comet? A rare but natural cosmic traveler? Or a story where we ended up seeing more than was really there? Let's take our time and look at it calmly. On July 1st, 2025, the automated Atlas survey detected a faint point of light. At first, it didn't look special. Telescopes record objects like this all the time. But very quickly, astronomers realized something was different. This object was moving too fast and along a trajectory too unusual to belong to our solar system.
It's traveling at roughly 60 kilometers per second. Its path is hyperbolic, which means the sun cannot hold it gravitationally. It doesn't orbit. It doesn't return. It passes through once and keeps going, back into interstellar space. There's another detail that rarely makes headlines, but matters a lot to astronomers. It's called orbital eccentricity. For 3I Atlas, that value is greater than 6. That's extremely high, one of the strongest signatures that this object truly came from outside our system.
Some estimates even suggest it could be incredibly old, possibly approaching the age of the universe itself. That number comes with large uncertainty, but the idea alone is striking. We may be looking at material that formed long before the sun, the Earth, or even our local cosmic neighborhood existed. So why does it matter that this is the third such object? Because before 2017, humanity had never confirmed a single interstellar visitor. The first was Oumuamua. It passed through the solar system and was detected too late, already on its way out. We had very little time to study it. Its shape appeared unusual, its behavior wasn't fully understood, and the lack of data left room for endless speculation.
And this time, something important was different. With Oumuamua, we noticed it too late. It was already leaving when we realized it didn't belong here. With Borisov, we were lucky, but it behaved exactly like a familiar comet. But with 3I Atlas, for the first time, we noticed an interstellar visitor early, while it was still approaching. That changed everything. It meant time. More observations, more measurements, and fewer blind guesses. And then, something interesting happened. As 3I Atlas moved closer to the sun, it disappeared from view. Not because it vanished, not because anyone stopped watching, but because of geometry. From Earth, the object moved into the same direction as the sun in the sky. The glare overwhelmed ground-based telescopes. For a while, we simply couldn't see it. This moment, when data pauses, is often where imagination accelerates. Because when observations stop, speculation fills the gap. Around the same time, international observation campaigns were announced. Some headlines framed this dramatically, as if governments were reacting to a threat. But in reality, this is standard practice. There are international systems designed to track near-Earth objects. Their job is not to hunt aliens. Their job is to measure uncertainty. They refine trajectories. They improve models. They test coordination between observatories. When something rare appears, especially something interstellar, it becomes an opportunity to train and improve these systems, not because danger is expected, but because responsibility requires preparation. In the case of 3I Atlas, the conclusion was clear early on. It poses no risk to Earth. Before disappearing behind the sun, astronomers noticed something unusual. A stream of material appeared to extend toward the sun. This was quickly labeled an anomaly, a so-called anti-tail. At first glance, that does sound strange.
Comet tails usually point away from the sun, pushed by solar radiation. But this effect is not new. In several well-documented comets, similar features were observed before. What looks like a tail pointing toward the sun can actually be an optical effect. Large, heavy dust particles move slowly. They stay close to the comet's orbital plane. When Earth crosses that plane, we see a thin line of dust edge on. From our perspective, it appears to point sunward. Not a jet, not a maneuver, but geometry. In some cases, slow-moving dust combined with weak solar pressure can also produce sunward features, without anything artificial involved.
While Earth-based telescopes were blinded by sunlight, spacecraft designed to observe the sun continued working. These probes weren't built to study comets, but with careful analysis, scientists extracted faint signals. What they found was surprising, but still natural. As 3I Atlas approached the sun, its brightness increased far more rapidly than expected, not by a small factor, but dramatically. This suggests that the comet began releasing material very intensely. In other words, it woke up. Looking closer, scientists analyzed the light coming from the comet. They found that much of it came from gas, not dust. This object is unusually rich in carbon-based gases, more so than water vapor, even at large distances from the sun. That matters. Carbon-based gases remain active at much colder temperatures than water ice. This strongly suggests that the comet formed far from its parent star, or spent an extremely long time in deep, cold space. In addition, researchers detected water ice and vapor, carbon monoxide, carbonyl sulfide, and traces of cyanide and atomic nickel. And here's what often gets lost online. None of these substances are exotic. They are commonly found in comets within our own solar system. So the picture that emerges is not strange, it's elegant. An interstellar comet with a chemical fingerprint shaped by a different stellar environment, but still fully consistent with known physics.
And yet, another narrative grew louder. Much of it traces back to astrophysicist Avi Loeb. He is known for asking uncomfortable questions. What if the trajectory isn't random? What if the outgassing behaves differently? What if something could be released along the path? It's important to be fair. Most of the time he asks, what if, not this is what it is. But nuance doesn't travel well online. Careful speculation turns into bold headlines, and bold headlines turn into beliefs. What's rarely mentioned is that Loeb proposed a scale, a framework to evaluate interstellar objects. It ranges from 0 to 10. 0 means a completely natural object, no anomalies, no special attention needed. 10 would mean confirmed hostile artificial technology. 3I Atlas, according to Loeb himself, sits at level 4. Not proof, not certainty, just the lowest threshold where artificial origin should be considered alongside natural explanations. Alongside, not instead of. This distinction is crucial. This brings us to a broader pattern. In the past, people spoke of the god of the gaps. When lightning, eclipses, or disease couldn't be explained, they were attributed to divine action. That habit never disappeared. It evolved. Today, when something feels unresolved, some people insert extraterrestrial intent. Not gods anymore, aliens. Because intention feels more satisfying than uncertainty. Social media accelerates this tendency. We're still collecting data doesn't spread as fast as this could be an alien spacecraft. So what really matters here? 3I Atlas is almost certainly not a spacecraft, not a message, not a mission, but that doesn't make it ordinary. It is a rare opportunity, a chance to study material from another star system, to compare how comets form elsewhere in the galaxy, and to understand whether our solar system is typical or not. And perhaps the most interesting part is not the object itself, but us. We still search for meaning. We still hope someone might be looking back,
and we still tend to project intelligence where physics alone may be enough. And that's okay. The universe is vast, and curiosity is part of who we are.
So now I want to hear from you. What do you think? Does the explanation of an interstellar comet feel convincing to you, or do you sense there's something more to this story? Share your thoughts in the comments. Subscribe to SkyMind so you don't miss future conversations about science, space, and how we try to understand reality. I'll see you in the next video.